Okay, so hi, my name's Brad, and I am passionate about the quality of software. When everyone says, hi, Brad.
Hi, Brad.
Okay, so powerfully simple planning framework. All right, so what I'm going to talk about is need for plans. And let me get this silent over here. Need for plans and go over some of the principles behind a planning framework that's in a methodology that we use here called team process integration, here being NavAir. Julie gave a background for me. It was really nice that when I was doing my doctoral work, my dissertation, I was able to use the data generated by a whole bunch of teams working on a whole bunch of projects to be able to do analysis on it to see how the planning worked and how the execution of the plans worked. And it was really nice to get that kind of insight. And so we've got a lot of principles behind this that are kind of proven in the field that we're going to share with you. All right, so the need for plans. Everybody runs on schedules and commitments. No matter where you are in the chain, you've got customers that want to know when you're going to be finishing your work, and you turn around and you have to depend on other people to provide you something or to deliver something or put a new version of something out for you. And they've given you schedules and they've given you commitments, and you need to know they're going to be able to make those on time. So there's a big long line of everybody telling everybody else when they're going to get done. And if you want to have a happy customer or a happy manager, then you want to give them some kind of status along the way that you are still online to be able to make that commitment. Otherwise, 11th hour, you're going to have a lot of very um, nervous customers not knowing whether you're going to deliver tomorrow or not. So to be able to tell someone accurately your status as opposed to saying, I'm doing fine or we're doing fine, which is not comforting, then you have to be able to measure your status. And so to be able to measure status, you've got to have a plan that you can measure from. All right, now on this slide here, you got a bunch of bold text, and that's not an accident because these are all important. So here's some fundamental principles behind planning when you're in this methodology. First off, never make a commitment without a plan. That means that if your boss's boss runs into you in the hallway and says, hey, Jimmy, while you're in there, I heard you guys are doing some work. Could you add this other button for me on the display? You don't say no, but you say, hey, let me get right back to you on that. And then you put together a plan and come back to them with a, hey, here's the impact, or here's how hard it's going to be, or it's going to cause other things to fall at the plate. Come back with the impact. Don't say no, but don't say yes without a plan. All right, and another one, super important, is when you're making a plan, the people are going to do the work, make the plan. I don't know how many of you have scars from being told you have 3 weeks to get this done, and then knowing it can't get done, but that person, your boss or your whoever's under that pressure is going to make your body pay that check, right? Or cash that check. So we don't do that. And it's very important to have the people doing the work make the plan. And oftentimes you have to plan without all the right data. And if you can't plan with all the right data, you're going to make your assumptions. You're going to plan on planning again. Now, you have a plan and it's not working. It doesn't fit what's happening. Change it. One of the things that's important is that the tools that we use at NavAir to do this kind of work is we have a baseline of what the original plan was. And so we have no hesitation to be able to change the plan because we have access to the original plan. You're collecting historical data, which you should be, then you should base your your plan that you're making now on your past performance. You shouldn't be going, I think we'll do twice as fast this time. I just hope we will. No. And none of the try harder stuff. Whatever you've mapped your team as their rate of getting work done, you should plan on that being the same way, unless you've made some change in your process or change your tool set, and you think it's going to have an improvement on your performance. Now, your historical data is going to be most useful when you consistently plan the same way, because then you have been collecting data that you need for the next set of assumptions for the next time you make a plan. So try to get a consistent planning process in place. Talking of planning processes, here's what we're going to be talking about. So I'm going to cover these very high level because we're going to cover them in detail in the next couple of slides. But given you've been told to do something, how would you make a plan to complete that assignment? And this is where it's incredibly simple. First off, you take that assignment given to you, and it could be just one thing. You take it and you break it down. And we call that a conceptual design. Be like you've been asked to paint the inside of a house. What do? Break it down into not just the house we're painting, where the rooms we're painting, right? And then you keep breaking it down like that as a simple example. More on that later. Um, Estimating how big each part is. Okay, so the example I just gave you, we have rooms we're going to paint. And so you can not all rooms same size. You may have a huge dining room and a little half bath that's shared with the rest of the house, right? So those are very small sizes, and they be very different as far as um, the time it takes to do them. And that's what you do next. Is once you've sized everything, big rooms, little rooms, then you take a look and talking about how to turn those sizes into times, and that's going to be driven by your speed at which you can paint. So a productivity rate, if you want to think of it. And so you work those two together to come up with now time. And so now you've been asked to paint the inside of the house. You've now broken it into, I got to paint these different rooms with these total times. So you can add them all up and you can tell how much time it's going to take you. Now, before you do it, if you want to show progress, then you may want to break those rooms you're going to paint down into the steps you take whenever you paint a room, like pulling all the furniture out, taping off the areas you don't want to get paint on, dot, 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 right? There's a couple of steps you have when you paint a room. And you would put that, paint this room with, you got to move the furniture out of that room, out of that bedroom. You got to put the tape around for the tarp for that bedroom, dot, 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 for each room. So you got a bunch of tasks. Now, you've got a amount of time for all those, and now you got to sit and figure out, when am I going to find the time to be able to do all of these tasks in this plan? And that's going to drive your date for completion. So now let's go over these in more detail. So part of what I mentioned a couple of slides ago is that using historical data. So here's the way you lay out your data so that you can capture it and feed it for the next plan. So here at the top right, top or left, customer tells you want to do something like paint that house, right? And so you take it and you then break it into what I'd call a pile of rocks. So you get this big hunk of rock in the beginning of paint the inside of the house. You break that into smaller rocks that are paint the individual rooms. And then you would take and you would look at your history about, hey, what are my typical rooms? Because what you don't want to get is bogged down by having someone go measure every room to figure out how big they are. And so you'd say, well, that's a small room, it's a big room, that's a huge room. And you'd look at your past painting of houses to say, what are my typical sizes for rooms? Instead of trying to get exactly, you can quickly say, well, it's a small room, it's a large room. And then the next step is to take that small room, look at your productivity and say, okay, that's going to take me X hours. And look at another room and say, that's a huge room, it's going to take me Y hours. And that's driven by how well you are, how fast you are at painting walls, right? Okay, so then you now have a pile of rocks that are not just the rooms, but the time for those rooms. And then you take those rocks and you turn them into tasks. And you look at your process about what are the steps I go through when I paint. And you sit there and say, okay, for every rock that says paint the house, I got 10 hours to paint that room. Then I turn that into the 5 steps that I'm going to use to paint that room. And I spread the 10 hours across those 5 tasks. More on that later. And then you got now that pile of rocks turned into a pile of tasks, still the same amount of time, maybe 50 hours or 60 hours to paint that house. And so now you look at, when am I going to find 50, 60 hours? And you look at your schedule and you figure out, well, I've got some hours every weekend to come around and do it. And so you'd figure out what your schedule is and be able to get a completion date. Then when you actually do the work, you're executing the work, you're coming in, you're painting that house, you get it done, you say, customer, the house is painted. And while you're doing that, you're also saving information on your actuals. How long did it really paint each room? How big was each room really? And other information, right? And when did I paint those rooms? And you put that and save that aside. And when you deliver or announce that the house has been painted, then before you jump into planning the next house you've been asked to paint, you look over your shoulder and say, so how did it go? I made these assumptions about the room sizes and the productivity rate and where the time is spread across the steps in the process. and my availability. And you update those that performance, your performance so far, so that you can use the latest and greatest information for the next time you do your planning. And that's how you do this. Three major pieces. Go through the planning, do the work, capturing data, and put that data into your performance information, so your actuals, so you can use that for the next time you plan. Now, conceptual design is not really straightforward. Let's talk about it for a few here. So on conceptual design, what you're doing is taking this problem given to you, and it might be a hand wave. And I'll give you some examples of that a couple slides here. But you're trying to sit there and say, well, what do I or my team have to do? What do they have to produce? What do they have to perform? What services performed, like teaching a class, um, taking some training. Those are services, and products might be to produce a paper, to dig a ditch, whatever it is. And what are you going to do to meet the customer's needs? And the customer may make it very simple in their statement, but you've got to really take it and break it down to what you have to do, all the implied requirements, right? And so this is your pile of rocks. And then you break that problem down into smaller parts until you get to the point where you can say, "Oh, I know what that is. I can. This is the floor for the. This is the bathroom, the half bath I have to paint, right?" And so I know. Okay, I can get a handle on that. And so you just want to be able to get a handle on how big you think they are roughly. That's going to help you take the next step, and that is to estimate the size of these rocks. Now we're going to walk through these concepts of these 5 or 6 steps in the process. And we're going to take on and look at an example of someone who's part of a development team that's making a Amazon, basically, a web-based shopping cart app. And this person's job is going to be to put a plan together for them to develop the test cases that need to be performed against this product. They're not going to do a plan on running them. They're going to plan on developing them. So we'll touch base with Jimmy here and see how he's using these concepts to make his plan. So a little more on the conceptual design thing. I use this rocks in a pile analogy, and I thought I'd just lay it out for you. So here you're given a problem like um, build a house. You're going to, and you got the blueprint, and someone asks you, how long does it take you to build it? You go, time out. I just can't come up with a number off the top of my head. And so to build that house, you may have to say, hey, look, I'm going to break it down into or let's say the painting. Sorry, let's think of the painting. So you sit there and say, well, I know I've got to paint a couple of different rooms. Or maybe you say I got to paint rooms and I've got to or move the furniture out first out of the entire house. However you're going to do it, you have some kind of break it down into pieces of things you have to do: moving furniture, painting the rooms, getting furniture back in. And so now you kind of understand the kind of stuff you have to do, like moving and painting in this case. And then you take it and break it down to the point where, like I talked about before, you're painting individual rooms. And this is again just the rocks. This is just the conceptual design part, not even the tasks. But you can say, oh, painting that half bath. I know I got a handle on that. I know what that is. And so you just break it down to the point where you can say, okay, I think I can understand how I can take this further and get more information about it. And the whole goal of this is to break it down to the point where you can put a size to these rocks in the pile, which is the next step in the planning process. So oftentimes you're given something that's you just can't handle straightforward and make a plan for it. So you break it down into the kinds of work, and there's different ways to break it down. And then you get to the point where you say, all right, I got to handle on these pieces. Okay, so back to our friend Jimmy, who's working on the test cases. His conceptual design is he looks at the work that they've been planning to do with the shopping cart app, and they go, well, his user interfaces, his business logic, and his databases. Those are like the big rocks he broke the huge rock into. And then he can look at those and say, well, how many interfaces are going to be? Oh, 10 screens? All right. And then he looks at the business logic and he sees it's going to be about 12 commands that he's going to have to write test cases for. And then the database got a ton of objects in there that you're going to have to write test cases for. So he goes, okay, all right, 10 cases for the screens, 12 test cases for the commands, and 40 test cases for the objects. And there's my pile of rocks. Haven't been sized yet, but at least it broke it down from developed test cases to, he broke it down into what, 62 different smaller rocks that he can point at and say, yeah, test screen for that logon screen, got it. Or test case for the logon screen, got it. Okay. So now, uh, when we looked at the rocks example, um, we could go through and talk about different size measures for those rocks. Like say the problem was, I'm going to build a house. And so you would say, well, I got to do, let's see, I got to do the foundation, the framing, the exterior, the plumbing, the electrical, drywall. You got a ton of things that have to be done in there. And one of them might be the flooring down, and you'd say, well, at the very end, I had the flooring for the different rooms. And so you have a size measure for that about probably square feet for each room. And that would be your size measure to differentiate how much time it would take me to put the flooring down for the master bedroom versus the half bath. Much different sizes, right? And then for another example might be that you are making modification to a lab bench. And so in that case, you look at it and you break the big rock into, oh, I got to make some panels, I have to make some cables. You say, all right, and you break it down further into what cables you have to make. You might have a simple power cable that has 3 or 4 wires in it that goes from some panel to the power conditioner. And you might have another one's a 50-pin cable. And someone's got to solder all those wires in there. And that's a custom cable. You can't buy it off a shelf. And it goes from, say, one of the new panels to a breakout box. And so the time to make that cable is very different from the time to make that power cable. They just 3 or 4 wires in it. And so having the soldered wires is a good size measure, you'd think, to differentiate between one cable and another. If you're writing, if someone told you, hey, add a weapon to an aircraft. As an example, my time at AV8B, just before I joined there, the Harrier, um, a requirement that came in the early 80s was, hey, or no, let's see, mid 80s. It was, hey, we got these weapons called side arms. It's a sidewinder, but it's an anti-radiation missile. They made about 700 of them from obsolete AIM-9s, and they wanted to put them on Harriers and helicopters. So someone told the team that maintains the software for the Harrier, says, well, add this sidearm to the aircraft. And it's like a sidewinder, so have at it. And then walked out of the room. And all the engineers looked at each other and says, the interface for a sidearm or for a sidewinder to the aircraft and the sidearm for the aircraft are completely different. And they just shook their heads and put their jaws up and said, all right, what are we going to do about this? And they started doing conceptual design of saying we have a bunch of requirements to write and we have a bunch of software to write. We have hardware changes to make to the aircraft because the sidewinder has probably, it's very simple, couple of cables that go to it, but a side arm would have a whole bundle of cables going to it for exchanging information about what target to go after and stuff like that. So totally different interface between the aircraft and the weapon, even though it still mounts on the same runner. And so in there you got, say for the set of requirements, you break it all the way down to a set of requirements maybe for the power up window for the pilot to power up the sidearm before he launches it. And that's a different set of requirements than another set of requirements. And the way you'd size that set of requirements might be the number of shells. Or if you're using some tool like doors, number of database objects. But anyway, there's a size in that one. And all that software, you'd have software for that power up window to be displayed. And that's going to be lines of code, right? So all these things that you're going to do to size after you've broken everything down in pieces, you're going to size them all. I mean, how do you know when you have a good size measure? Well, one of the things you want to have for your size measures, and you see they're all over the place. It could be anything, as long as it's some kind of relationship to labor, because no matter what's in that pile of rocks, you're going to turn it all into a bunch of tasks with time. And so you want to have whatever size there is for that rock related to time. And so you'd see the square feet, more time. Soldered wires, more time. Dot, dot, dot. So that's what you want to have is something that's useful for that. An example of when it's not a good idea is the number of ideas in a white paper. Okay. So how many pages would it take to bring across an idea? Probably not a good one, right? Precise. When you talk about precision, you want to be able to say, if I give this to multiple people and they try to measure it, using that size measure, will they come to the same number? So as like a white paper, if I use pages, and I wrote a paper up and handed it out to two people. They open it up in Word, look at it and say, oh, Word says it's 3 pages. Well, if I then gave them the white paper and said, how many ideas are in this white paper, I'd probably get two different answers from them that aren't even the one that I know is how many ideas I put in the white paper. So you don't want it subjective, you want it objective. Now, last one's important, directly countable. You don't want to spend a lot of time constantly remeasuring how many items are in that or how big that object is, the actual size. Square feet floor, there's apps now for phones that use augmented reality, and you just walk around the room and scan the room, and it figures out the square feet of the floor for the flooring. Uh, or or you can even have another one that uses augmented reality where you point at the set of cables that the wires are spread out. It'll count the cables, the wires for you. Incredible applications now that do that automatically. Hardware aspects, right? Um, uh, Word will tell you how many shells there are in the Word document, if it's Word. If you're indoors, something like that, they'll tell you how many objects there are already. Lock, there's lots of line counters to tell you how many lines of code there are in a section of code. So all these things can be counted automatically, and that's what you want to make sure is that you can have something that can be handled like that. All right, so now at this point we've got the pile of rocks that have been sized with like t-shirt sizes, small, medium, and large. So here's the idea behind a proxy. And this is the next step is that the third step is that once you've sized them with the t-shirt sizes, you turn them into actual sizes. So it's tough in the beginning when you're planning to figure out, well, how big is it going to be? And these proxies that you're going to see me illustrate right now with a house are a way to make it and blow through that and make it a small part of your planning and B, easier to do. Now, if you've ever talked to someone who builds houses and you want to ask them how much is it going to cost to build a house that meets your requirements, they'll say, well, what do you want? And you start talking about the rooms in that house and their relative sizes. You don't say, I want a 300 square foot bathroom or bedroom. You'd say, I want a big bathroom or a big bedroom, a master bedroom with a big ensuite, right? And so this guy has got a clipboard. He starts putting checks in a box. What is he doing? He's got a list of the different room types. And when he builds rooms in houses in a certain area, because this is very important, you build houses in Ridgecrest, for example, very different than gutting an apartment in New York City and reformatting it to a different floor plan. Totally different sizes. And so even houses in different cities would be different sizes. So you would have to have that history of building houses in that area. And so he built these from his experience, this table. And so when someone says, well, I want a medium bedroom, he knows it's about 150 square feet. And same thing with these other ones. So he sits there and he starts checking off. You want a large master bedroom and an ensuite bathroom? Okay, got it. And then he goes, well, I want a couple more bedrooms and a bathroom for the rest of the house. Got it, got it. And I want a kitchen and the dining room a separate or living room separate from the dining room, and I want a killer man cave, right? And so he's checking these things off, and does anything else? Because no, that's about how I would do it. And then he takes it and he does the math and he puts it all together, adds a buffer to it for hallways and stuff like that and closets, and goes, all right, 2,200 square feet, and then he multiplies it times his dollars per square foot and gives you a quote. And that's all while you're standing there talking to him. This is the trick for proxies, is that you have some hand wave, small, medium, and large, with some kind of standard. And assuming that assumptions are right, you can turn that relative sizes into actual numbers. All right, so what if you don't have that kind of history? Well, you can make it pretty easy by just taking and coming up and like, for example, say requirements. You take a set of requirements that you wrote, last 3 projects you did, 20 sets of requirements. Look at each set, see how many requirements are in each one, take them all together and divide by 20, and there's your typical average set of requirements. How many are in a typical average set? And then you can just double it and have it and have it. And that's your line in the sand. Use it a couple of times to figure out if it works well. If it doesn't, you may have enough data to be able to do a more finesse related way of coming up with your large and smalls statistically. So, but this is the simple way to get the ball rolling. So now going back to Jimmy with his test cases, he can look at those and say, well, this is going to be small, medium, and largest. And notice that there aren't a bunch of, and most of them are mediums. He looks at them and says, well, yeah, there's a bunch of really small ones because the database object is really easy to test. So he's now sized his by talking to the team about what they expect to have on those screens, and he can then come up with his relative sizes. And now he's got them sized relatively, right? So now let's turn those relative sizes into labor, time. So if we get into that, let's talk about the time. One thing that everybody does is they work a full week to get paid a full week's worth of work. But do we want to count all that time as the time it's going to take to do and compare it to the time to do this job? And so oftentimes you don't work all of your week on the job. You have other things that are pulling you off, whether it be another project that you do part-time or whether it's other constraints that you have to support, like playing nice in sandbox and answering your phone when it rings. And so you're looking for some kind of relationship between the work you spent on the project and the work you made on the project. And so we're going to separate your week into the task time where you're working on the project and the rest of the week, which is just doing whatever it takes to get the job done, to be employed, right? So on the left here, you see these pieces like if you're writing requirements or you're designing and coding, or if you have services you have to provide as part of your rocks in your pile, whatever you're doing in your plan, those are the things you should be logging task time or capturing task time to. And these other things, they're necessary, but they don't contribute to getting any progress made on your pile of work you have to get done. And that's like status meetings. Even on the project you're working on, no one's making progress on those rocks while they're in a status meeting. So keep it short, right? Mandatory training, that's a big thing at NavAir. It always pulls you aside. Answering the phone calls and emails, all that kind of stuff. That all contributes to pulling you away from getting the work done here. I call it it's a running gun battle between a world of squirrels and getting your job done. And so what we want to do is try to figure out the availability of, given your work environment, how many hours a week can you get on the pile on the left? And it's not so important to understand where your time goes on the right. We just want to know it's not over here. So if we can just figure out what percent of your week is over here, then that'll help us. And if that's too low, you can actually take steps to try to bump it up, like having quiet time at the beginning of the day, where no one expects the phone to be answered before 9 o'clock, for example. So here's where I want a little user involvement here. I want you to put down in the chat. See if I can pull up my chat. So I want you to put down in your chat how many hours you think are task hours in your 40-hour week. So this is where you're going to put something less than 40. So if you guys can enter some numbers in there. Think about you're on a project or multiple projects even. How much time do you spend working that project as opposed to all these things I showed you on the right about coordination and status meetings and phone calls and emails? Got a couple numbers in the 15, 25 range. There's a 45. Go, Steve, go. 25. Okay. All right. These are pretty reasonable. So when you're in this kind of world, there's two major, I could call them extremes, but there's two that separate from each other. They're different enough that we're talking about. One is when you're doing product-based work. You're creating something. You're laying it out, something that didn't exist before, and you're creating it to solve a problem, to meet a need. Whether it's a set of requirements that didn't exist or software to implement a set of requirements. These are creation tasks where you're creating something. Can't do that 24/7. It starts to burn the head out, burn the brain out. Now there's a different kind of work that's called service-based, where you're not creating a solution, you are regurgitating what you know already. When you're teaching a class, you're doing service-based. When you're answering a help desk, most of the questions may be answered by what you know. When you're maintaining accounts for a version control software, those are all things that you just crank the handle and you can do all day. And so you can spend more time doing it while these people they have to take a break or else they just lose focus and they don't get anything done. Um, I've had one team lead try to maximize his hours. He was the software developer. He had 20. It's his glass ceiling. He couldn't go past it. He was trying to delegate everything, but he was mentally getting beaten up and couldn't sustain it. Now, what's yours going to be? You need to measure it. But this is the separation, is that you want to just capture the time you spend on your pile of tasks versus the other stuff and understand your availability. That's one of the two big shoes. How much work do I have to do and how available am I to do it? And that's what helps you determine a date for your completion. Let's go back to Jimmy for a minute and look at him getting a time for his pile. Now, this is just the test cases for the user interface. Now, he's got 3 large, 5 medium, and 2 small. That was just 10 test cases for his user interface screens. And he didn't use a size. Just like in Scrum, you have story points. You don't say how many lines of code you're going to write. You just say, give me 3 story points to do it. So, so in here, you could use either you have a size, like I got to dig a ditch, it's 30 feet long, and I dig it at 3 feet per hour. I need 10 hours to dig that ditch. Or you may have something that has time in the proxy table. Either way, you don't have an argument about, well, no, it's going to be 2 or 2.5. What you do is you limit the discussion to small, medium, and large, or larger or smaller, and they have to pick the lesser of all evils. And that's what makes it go fast. You don't have an infinite number of decisions. You say, I've got 3 or 4 choices to make about what size that test case is going to be. And you pick the one you think is most likely to be the best fit. And that makes the going from size to time really fast. Now, one of the last steps is breaking the problem up into tasks. Instead of a pile of rocks, a pile of tasks. So in this one here, we're looking at is the steps you're going to take to produce that product, to put the floor down in that room, or to paint that room, or to dig that ditch, or to write the requirements. Those are all different kinds of parts, and they all have different kinds of processes. So you take the steps for one process for that kind of rock, and you simply take the 10 hours for that rock, you spread them across the tasks, and it's a swap out. So your pile of rocks becomes a pile of tasks. The amount of time doesn't change. You spread it across those pieces. Now for Jimmy, his process for developing test cases is 4 steps. Now we're not going to teach you how to develop test cases, and there's thousands of ways to do it. This is just his. He's got 4 steps, so he's going to do those 4 for each of the 10 test cases that he's going to write for the screens. That's 40 tasks, right? Okay, so we look at this, and he goes, well, we're going back a couple slides here. He has 24 hours to do those 10 test cases. Well, 40 tasks over 24 hours, that's going to be like a task every half hour. And that's too detailed. So he goes, I don't need to be that detailed. So I'm going to do this step for all 10 test cases for the screens, this step for all 10, this step for all 10. So it's going to spread the 24 hours across 4 tasks. And this is what you can do, is you can sit there and say, well, I don't need to have a bunch of half-hour tasks. So he spreads his time across these 4 pieces. And he knows historically, this takes a third of the time, a sixth, eighth, sixth, and a sixth. So there's his breakout of the 24 hours for the 10 test cases for the screens. Now he's got another 52 test cases. He's doing this to those 2. So he's really got a pile of 150 hours of work, right? Now, this idea here about how do you show progress, or how do you be able to track progress, you're going to use the concept called earned value. And earned value, you take the planned time for a task, like the 4 we just did, compare it to the planned time of the total pile. Let's just look at the 24 hours for now. And then you do that math. Say, how big of a piece of pie, how much of the pie is this piece? And so, for example, a 4-hour task, 24 hours of work, that one piece is a sixth of the pie, you see here. And the cool thing about earned value is that it's objective. You can't ask when you're almost done or how are you doing. They say, well, I finished these pieces, I haven't finished these pieces. It's black and white. There's no, I'm almost done with a couple pieces. Because what you do is you don't get any credit unless you finish a task. So you either get 8 hours of credit or get credit or you don't get credit based on whether it's kind of done or not. And here's the cool piece. The earned value you get, the credit you get, regardless of the actual time it takes you to do the job, is based on the planned time. Hence the desire to make sure the planned time is as close to what you think it's going to really take. Okay, this is a really good way to track progress objectively instead of when you ask people how they're doing, they say, I'm doing okay, I'm doing fine. The data, what tasks they have signed off, which they don't have signed off, speaks for itself. So last slides here, we have our friend Jimmy just looking at the 4 test cases for the screens. He's got these 4 tasks, he's estimated sizes for them, and as he finishes them, he would get progress, like a third of the pie eaten, 2/3 of the pie eaten, 5/6, and all of it. That's the order he's going to do it. So the trick is to figure out, well, what's his plan? When is it going to be done? Well, here is each row is a week, where his availability of 10 hours a week. And so he says, well, how far should I get after the first week? Takes that 10 and comes over to here and says, how far should this pile should I be able to get? Well, I'll finish this first one, but I won't finish the second. I need 16 hours to do that. So I should be at 33% at the end of the first week. And there's that number. After the second week, I should have 20 hours of progress made. Come up here, where should I go? Oh, on Friday at 5 p.m. on the second week, I should be putting a bow on the third task. So I should be 5/6 done. And that's where this 83 comes from. And then the third week, he's got 30 hours, more than enough to finish 24. He should be 100%. So now he's got weeks with how far should I be? And that's what helps him draw a plan. So now he knows what pace he has to have. Starting now, first week, second week, third week, I should be done. And then when he starts doing the work, he can compare his progress to the plan and say, oh, shoot, I'm behind. I really need to kick in the gear, spend less time at the water fountain, whatever it is, right? Whatever's pulling him away. In the second week, you say, well, I'm closing the gap. Good. I'm making there. I've got a better chance of finishing on time. Now, this is a hyper fragile four tasks over 3 weeks. But imagine like his pile of 60 tasks over 6 months. He'd be able to have a plan all the way through the 6 months, or a sprint, 3 or 4 weeks, or a cycle, 3 months, and be able to compare his progress to his plan objectively. So, wrap it up. To make plans, you need to have a process to do the planning and a framework that supports it. Standards, what time counts, proxy tables and processes are we laid out, right? So to control your work, make sure that you make your own plans and you make your own commitments so that it's not a matter of, well, yeah, they want it done in 6 months and there's no way it's going to happen, but I'll tell you 6 months. No, you make the plan, you then have the power to negotiate with what the date could be or should be, maybe even earlier than they want it. And so that planning, conceptual design, break it rocks into smaller rocks, size the rocks using like t-shirt sizes, and then go to a proxy table, get the actual sizes or get the number sizes, turn those sizes into time using a productivity rate, turn those rocks in the pile into tasks using a process for each kind of task or each kind of work, and then figure out your availability to get that pile of work done. And that, using earned value, will help you not just plan your work, but track your progress. So, went a little long. We got time for questions though. So, any questions? I wasn't able to look at the chat.
That's perfectly fine, Brad.
Okay.
Yeah, if anyone on the webinar on the Tech Talk has any questions for Brad, please feel free to either put them in chat or unmute and ask your question directly. Well, Brad, I had a one thought. So first of all, just on what you were talking about just now, you were mentioning, tracking by week. But I know a lot of teams, they're doing like 2-week sprints. Could you track by day instead of by week?
You sure could, but your data would be really frail, especially on the earned value aspects. But it would be helpful to make sure that you are getting time on the project instead of weekly. I have a team that's doing Scrum, and they touch base twice a week, so midweek and end of week. And
Mm,
what another thing they do is um, they have a they have a daily chat that they have running, and so they have everybody report daily about what they're going to do today and what they finished yesterday. And so the team lead can look at that chat, and he sees whether someone's falling behind or not just by looking at nothing done yesterday, nothing done yesterday. You can see that and talk to them one-on-one offline, but they all get together midweek and end of the week to talk about their progress because a sprint, they do 3 week sprints, and they see that even 2 weeks was too short, even on daily. And because the dailies were starting to cut into their development times, there's so much time for the dailies stand-ups, and then they made 3 weeks, and they're now doing it twice a week. They get together for half an hour. So yeah, you can do the daily progress, but really maybe every half week
yeah,
or
some kind of compromise between every day and
yeah,
like every
earned
week is
value.
probably not granular enough.
Yeah, earned value would be really tough for daily, but
Mm.
time on task, that'd be good because then you'd know halfway through the week, I'm getting good time, good. And you have time to react to it and take action on it to hit the throttle for the second half of the week. Okay.
So Matt just put in chat a question. How do you handle new or changing requirements? That's an excellent question.
Yeah, it is. So one of the things about this methodology is the plan is not static. I don't know if you've ever been to, I worked in a contractor facility when I was in the government, and the contractor facility had this big, huge Gantt chart that was like the length of their cafeteria, and it overlooked all the cafeteria tables. And it was this Gantt chart that was like 3 years long, and it had all these. This gets done, then this gets done, this gets done, and they're all associated with each other. And it was on yellowing paper, and the corners were curling. And it went up there forever, and everyone laughed at it because that wasn't the plan anymore. And so one of the things that we do in this methodology is that you have a plan, and tomorrow it's going to change. And so you establish the ability to baseline that plan so you know what the original plan was. But at any given time, you're going to have new requirements, new priorities, a different order of turning things in. That's the prerogative of customers. You have to be that tail that's wagged by the dog, right? So one of the things you want to do is you want to make sure that your plan reflects what you think is going to happen from this point forward. Don't change your plans assumptions that things you got done to match your actuals that have already happened, but make sure whatever isn't done has the best estimate going forward that you think is going to happen. So if the customer says, no, you can't use that tool, you have to use this other tool. You go, well, that's going to double my productivity rate. So you go into your plan and you add more time to all the tasks. You tell them, hey, I'm only going to give you half of the requirements in 6 months. They may go, that's fine. But you make sure your plan reflects what's going to be your reality from this point forward. And do not hesitate to change the plan. Good question, Matt.
So another question, you're kind of talking to a little bit on slide 20, but I'm wondering when you're trying to size the rocks, right? How do you know what's the correct level of granularity for a rock? How do you know if you've broken down the problem enough or too much? Like what kind of criteria would you have in mind?
Well, actually, this collapsing of the 10 test cases, instead of having 40 tasks, having it be done in 4 is a great example. Because on one side, if you break a problem down, so you have a bunch of half-hour tasks, that's not going to help anybody. Because the reason why you break it down into tasks is to show progress every week. That's really the function of breaking your your problem down into the task level. So that you can tell you if you're on a team, you can tell the rest of the team, I got some things signed off this week. But because if you break it down too much, you spend time going back to your plan, whatever tool you're using to sign off tasks every inhale, sign off a task, exhale, that doesn't help anybody. So if you get down to the point where you have lots of tasks signed off every day, you've broken it down way too far. Now, just like I showed on, you have a script or a process. You use this to guide you when you're doing your job. So here's all these steps inside of a task. you use this to make sure you don't forget to do something. So you don't have to have tasks to remind you to do something. You use the process script to remind you to do something. And you have the tasks at the level that you know you're going to show progress every week. So that even if you're directly reporting your customers an army of one, you can tell them, I got some progress done. I'm at 44% instead of 22%. So that's on the one side. You can bring things together if you're too low level. If you find out all your tasks are 3 or 4 weeks long, that's another way of saying you need to break the rocks down more so that when you turn them into tasks, you have tasks which are less than a week of labor. And a gouge might be 10 hours. I don't care how many hours you get, whether you get 15 hours or 20 hours a week. If you just make sure that they're in the 10 plus or minus 5, that'd be good. But that's your gouge, is that you turn them into tasks, you see the tasks are all 30 hours each. You need to go back and break the rocks down more and then turn them into tasks again. Okay.
And I presume it still has to be to a point where you can visualize what those rocks are. I mean, they have to be similar to other things that you've done in the past.
Yeah, and also you need to be able to make sure you know when you're done with the task. So if you're to say, well, I've got this design to do and it's 30 hours, so I'll just take the first 10 hours of design to be one task. And second, no, you don't want to do that. You want to break that design up. If it's a 30-hour design, you may say, okay, I'm going to design this part of the solution, like the user interface, and I'm going to design the inner workings of the logic on another case, and then another one is the outputting of the results. You want to break your design into pieces, or else you go back to the higher level and say, I have to say, for example, developing software. I'm going to develop the software for the interface, and it'll be design, code, and test, and the software for the inner workings, logic, design, code, and test, and then the software for the outputting, design, code, and test. Either way, you don't want a 30-hour design, so you have two ways to break it up. Either break up the design or break up the rock that led to the 30-hour design and make sure that when you break that rock into design, code, and test, that they're smaller than 20 hours, maybe in the 10-hour range.
Trent just posted a question in chat. He said that, you said you had experience prior to Agile. Maybe you could reflect on how you perceive advantages and disadvantages of Agile compared to, he used the word waterfall, but maybe waterfall isn't always the exact word either, maybe less Agile. Do you view Agile as valuing people more so than older ways of working? Um,
So
I'll let you, don't want
yeah,
to create too much controversy, but you may have valuable perspective there.
we got some time, right? So I can give more than a single line answer. Okay, so when you compare what Agile, and probably the most common Agile is Scrum, um, and you compare that to waterfall, or what they call, the people do waterfall call it traditional, where you would do like a state, like someone gives you a problem, you have a stage where you do your requirements, then another stage where you do all the design and all the code, and everyone
Plan
looks
driven
at,
versus change driven is
yeah,
another common definition. Sure.
yeah. So the pluses and minuses of that are, the major pluses of Scrum are you're giving something to the customer, a minimum viable product that they can look at and say, "Oh, I don't like that," or "Can you make it bigger? Can you do it differently?" Or "That's the wrong approach," right? Give them feedback right away. You're only 6 weeks into the project and you're getting feedback saying, "Okay, let's start over." Well, in traditional, you might be months and months into the project before a customer sees it and goes, "What are you doing?" Right? So that's a big benefit of Scrum. But when you do traditional, and don't think of traditional as 6 months of design, 6 months of code, that was the case. I did in the 80s, I did some work on a war game simulation, and we did that. We converted a war game simulation from Fortran to Ada, and we did 6 months of design, 6 months of code. It was miserable. None of the software developers liked it. And so what you do now with traditional is you would take your problem and break it into, like I talked about before, about I'm going to develop the user interface. And so I do design, code, and test for a portion of the user interface and another portion, another portion. So you have a bunch of little design, code, and tests. And the customer might not get it until 4 or 5 of these rocks are done. And that would be the next viable project or product in the traditional world. But no one does 6 months of design, 6 months of code. Now, what's the benefit of traditional? Stability of requirements. Um, if there's a long lead time and you've got a customer who's thinking way far out and they give you a set of requirements that are stable, then you can do a more thorough design, like a high level design, instead of in a scrum where you're going, hey, we got a sprint going, let's get this done. And you're doing design, little micro designs, and you have to do refactoring, and you may suffer some significant rework and refactoring. That's not implementing new requirements, but shifting stuff because an item came through that just caused everything to turn upside down. So that's the benefit of traditional, is if you have the stability of your requirements, you can have those overreaching or more encompassing designs, so you suffer less rework, less likely to suffer rework as you're doing the development. So strengths for both of them. And it's all driven by the stability of the requirements. And in avionics, military avionics, you oftentimes have long lead times because someone is looking out years ahead saying, we're going to add AMRAAM to this aircraft in 2026. And they know to get the requirements in order to be able to do that. And that's what they're paying for in 2026. So a lot of long lead times. You have a roadmap, you have stable requirements at the high level, and the details might change because you have a pilot that's going, I don't like this interface. There's too many screens to go through before I can shoot it. And there's your feedback, right? But Scrum doesn't buy you much in that environment. You know, so anyway, there's the pluses and minuses. Hopefully I didn't get too far off the line there.
I would argue that what you described is really quite agile, because you mentioned that when there's new information, when there's changes in priority, when there's new requirements, additional details come in, you said you don't hesitate to add those tasks or modify the estimates, or get the latest projections based on from this point forward. So
Oh, by the way, Steve, you just reminded me, what I just showed you right now, this planning methodology. Sorry, I should probably make this relevant to the discussion here. Uh, where is that? This guy. This can be used for agile or traditional. This is not one or the other. In a PI, you might use this in a PI in a Scrum environment to figure out what your rocks are in your backlog. I mean, you have, okay, what are we going to do for the next? I wouldn't do a plan for each sprint, or if you did, it would be an hour long. Or you do a micro plan, right? Say, okay, we got these 5 items, okay, or these 10 items are going to be part of the sprint. What are we going to do? And you would, boom, you'd make sure they have story points, and you'd walk through this and say, okay, let's break those items into, and of course you have like Jira. Jira, you'd have the items. The tasks would be in some other tool, unless you format your Jira to work with tasks, uh, which might be able to be done, right? So you could do this for a sprint, or you definitely do it for a PI,